A single vertical robotic parking system can accommodate twice as many cars in the same space as a traditional parking garage. In Kuwait, there is a system that stores more than 2,300 vehicles in a space that would normally hold only half of that. Imagine never having to look for a parking spot again or worry about scratches on your car. But how do these futuristic structures manage to organize hundreds of cars without human intervention? How do robots and elevators work together to park your vehicle with millimetric precision? In this video, we will explore the fascinating world of vertical robotic parking systems. We will discover how they work, what their main components are, and why they are becoming increasingly common in large cities around the world. Stay until the end to understand how this technology can revolutionize urban space and make our cities more efficient. Vertical robotic parking systems represent one of the most innovative solutions to a problem that affects all the major cities in the world. The lack of urban space combined with the constant increase in the vehicle fleet creates a significant challenge for urban planners, architects, and public managers. These automated systems are not a new idea. In fact, the first automated parking garage was built in Paris, France, in 1905. Known as Garage Rue de Pontier, this pioneering system already used an internal elevator to transport cars to upper levels, where attendants parked the vehicles. In the following decades, especially in the 1920s, paternoster-type systems emerged, which functioned like a Ferris wheel for cars. These systems could park 8 vehicles in the space normally used for just 2. Mechanically simple and with a small footprint, the paternoster was easy to install in many places, including inside buildings. Today, there are thousands of these systems in operation around the world, especially in countries like Japan, China, Germany, and the United States. In Japan, for example, it is estimated that there are more than 1.6 million spaces in automated parking systems. To understand how a vertical robotic parking system works, let's follow the journey of a car from the moment it enters the system until it is retrieved by its owner. When you arrive at a vertical robotic parking system, the first thing you encounter is the entrance terminal. This space looks like a common garage, but with a fundamental difference. Here you don't need to look for a space or maneuver on narrow ramps. You simply drive to the entrance terminal and position your car on a metal platform called a pallet. Laser sensors create an invisible frame that precisely measures your vehicle's dimensions, its exact position, and even its height. These sensors ensure that the car is correctly positioned for parking. All these mechanical components are coordinated by a sophisticated computerized control system. This system manages vehicle flow, optimizes space utilization, and monitors all aspects of the operation. Vertical robotic parking systems offer a series of significant benefits when compared to traditional parking garages. Let's explore the main advantages that are driving the adoption of this technology in cities around the world. The most evident benefit is space efficiency. A vertical robotic parking system requires, on average, 50% less land area to accommodate the same number of vehicles compared to conventional parking garages with concrete ramps. This happens because we eliminate the need for access ramps, circulation corridors, and space for door opening. To illustrate this efficiency, let's consider a real example. A conventional above-ground parking garage in a certain area occupies 80,729 square feet and provides 291 spaces. In comparison, a smart parking system in the same region has 308 spaces distributed across 12 floors with a total height of 105 feet, occupying only 8,073 square feet. This means that the smart parking system uses only 10% of the land of the conventional parking garage while offering more spaces. Another important benefit is security, both for vehicles and for people. Since there is no public access to parking areas, the risk of theft and vandalism is drastically reduced. Minor damage common in parking lots, such as scratches and dents caused by neighboring car doors, are completely eliminated. The user experience is another aspect that improves considerably. Parking becomes a quick and stress-free process. There's no need to drive in circles looking for a space or worry about maneuvering in tight spaces. The average time to leave a car is only 90 seconds, and retrieval usually takes less than 3 minutes. Environmental benefits are also significant. Since cars don't circulate inside the parking garage looking for spaces, gas emissions are reduced. Ventilation systems can be minimized, and lighting can be reduced or even turned off in storage areas, saving energy. From an economic standpoint, vertical robotic parking systems also present compelling advantages. Although the initial investment may be higher, the cost per space often ends up being lower when we consider the land value. To better understand how vertical robotic parking systems work in practice, let's learn about some real examples implemented in different parts of the world. The world's largest automated parking system is located in Al Jara, Kuwait. This impressive system offers 2,314 parking spaces. To put this in perspective, a traditional parking garage with approximately twice the area would be needed to accommodate the same number of vehicles. In Germany, in the city of Wolfsburg, we find the world's fastest automated parking system with a retrieval time of only 1 minute and 44 seconds. This impressive speed is achieved thanks to a highly optimized system that uses multiple elevators and conveyors working together. In China, the Dalian Runde Plaza is a notable example of how robotic parking systems can solve specific urban space problems. Located in a prime area of the central city, where space for both parking and people is extremely valuable, the project faced significant limitations. The solution was to implement a robotic system that offers 124 spaces distributed across 6 underground floors. The system uses 2 conveyor robots and can move up to 140 cars per day, with an average access time of only 90 seconds. In Europe, the largest automated parking system is located in Dock 1, in the city of Aarhus, Denmark. This impressive system offers 1,000 parking spaces through 20-car elevators. In the United States, a notable example is the Brickell House parking system, a 46-story luxury condominium in Miami. This system is considered one of the largest and tallest automated parking systems in the world. Despite all the advantages, vertical robotic parking systems also present challenges and important considerations that need to be taken into account during the planning and operation of these systems. One of the main challenges is related to high traffic volume situations. Although these systems work very well under balanced flow conditions, such as in shopping centers and train stations, they may face difficulties in applications with very high volume peaks, such as during rush hours or sporting events. To mitigate this problem, the most modern systems use advanced queue management algorithms and multiple entry and exit terminals. Some systems also implement scheduling features, allowing users to request their cars in advance through mobile apps. Better distributing demand. Another important aspect to consider are the technical and maintenance requirements. Like any complex mechanical system, robotic parking systems require regular maintenance and may face occasional technical failures. As cities continue to grow and urban space becomes increasingly valuable, vertical robotic parking systems are positioned to play an even more important role in the future of urban mobility. One of the most promising trends is the integration of robotic parking systems with the smart cities concept. Imagine a system where your car communicates directly with the parking system, reserving a space before you even arrive at your destination. The connection with electric vehicles represents another important frontier. Robotic parking systems are ideal for integrating charging stations, since cars remain parked for extended periods, and the system can efficiently manage the charging process. Vehicle recognition technology is also evolving rapidly. More advanced systems will be able to automatically identify each car through license plate recognition, vehicle characteristics, or even direct communication with the automobile's electronic systems. Perhaps the most interesting development is the adaptation of these systems for a future with autonomous vehicles. When cars can drive themselves, the parking process could become even more efficient. We have reached the end of our journey through the fascinating world of vertical robotic parking systems. We have seen how this innovative technology is transforming the way we store our vehicles in modern cities. Recapping what we learned, vertical robotic parking systems use sophisticated automated systems to transport and store vehicles in vertical structures, maximizing the use of available space. The benefits are numerous and significant. These systems can accommodate twice as many cars in the same space as a traditional parking garage, offer greater security for both vehicles and people, provide a more convenient experience for users, contribute to environmental sustainability, and often represent an economically advantageous option in the long term. Examples around the world, from the largest system in Kuwait to the fastest in Germany, demonstrate the versatility and adaptability of this technology for different contexts and needs. Looking to the future, vertical robotic parking systems will continue to evolve, integrating with smart cities, electric and eventually autonomous vehicles, creating even more efficient and sustainable solutions for urban mobility challenges. In a world where urban space is increasingly valuable and cities seek more sustainable and efficient solutions, vertical robotic parking systems represent a truly transformative innovation. The next time you park your car in one of these futuristic systems, remember the incredible engineering and technology working behind the scenes to make your experience more convenient and contribute to a better urban environment. If you enjoyed this video and want to learn more about other technological innovations that are transforming our cities, don't forget to subscribe to the channel and activate notifications. Thank you for watching, and see you in the next video.